The interim report is out on the Swiftair cargo aircraft 737-400 that crashed in Vilnius, Lithuania back on 25 November 2024. We now know exactly when the System B hydraulic pumps were turned off, preventing the crew from properly lowering the flaps, and the crew did not capture this mistake until it was too late. Let's get into it. Both crew members, the captain and first officer, were from Spain. The captain was 48 years old and had been working for Swiftair since 2011. Before flying the 737, the captain flew the ATR, and he also had a position as a commercial manager within the company. The captain had a total of 5,432 hours, over 1,900 hours of ATR time, 1,600 hours of first officer time in the ATR, almost 1,300 hours as a 737 captain, and 557 hours previous to Swiftair. Remember, overseas, the standard remains the same, as you can get hired with an airline with a commercial rating and 500 hours. The co-pilot, also from Spain, 34 years old, had been with the company just since February of 2024, so about 9 months. He had a total of 520 hours total flying time, 190 of those hours in the 737 as a co-pilot, 329 hours prior to Swiftair, and was otherwise current and qualified. The aircraft was the Boeing 737-400 set up for freight hauling, and the load and the airworthiness of the aircraft were verified. The 737 has 3 hydraulic systems: System A, which runs off of the left engine plus an electric motor-driven pump; System B, which runs off of the right engine and uses an electric-driven motor pump; and a standby system using an electric motor-driven pump. Normally, with any one of these systems, you can continue to fly and land the aircraft. But with System B completely in op, you will not be able to lower the flaps normally unless you use the electrical alternate flap extension system, which is a very slow system, and in this accident investigation they found that the alternate flap extension system was not used at all. In fact, the red guarded switch or safety wire was still attached to the alternate flap extension system. But with System A operational, you'll still get your main gear and spoilers. And of course, flight controls. The switches to control the hydraulics are located here in the overhead panel, and the switches to control the engine anti-icing and wing anti-icing are located right above the hydraulic switches here on the overhead panel. There is no ICAS or engine indication and crew alerting system on the 737. More on that in a minute regarding the MAX. Instead of an ICAS system, you get a series of warning lights and cautions. The weather at the time of the accident: the winds were 170 degrees at 17 knots, visibility greater than 10 kilometers, but an overcast deck at just 700 feet above the airfield. Air temperature was just 1 degree Celsius, dew point -1. So given these weather conditions, plus the clouds the crew was to fly through on the approach, this would be conducive towards using the engine anti-ice. The flight data recorder and cockpit voice recorder were recovered, and the data was good. At the accident site, this was the condition that they found the switches. The engine anti-ice switches were in the off position, and the hydraulic pumps for System B, both electric and engine, were also found in the off position. The landing gear was found in the down and locked condition, the flaps fully retracted. Though the actual flap handle itself was dislocated, they found witness marks at the flaps 15 position, which corroborates, along with the CVR data, that the crew did attempt to lower the flaps to flaps 15. And as discussed in previous updates on this crash, all the nav aids were working, and the crew flew the published approach as published, though a little hot, a little high, and overshooting final approach here in the final turn. And if we look at the FDR data, the final moments of the approach, we can see them coming in high above glide path. They captured the final approach fix altitude, and then were still a bit above glide slope, and then dropped off below the glide slope, impacting the ground right here. Here we can see the overshoot of the final back onto the localizer, looking down on a vertical view. Localizer and glide slope deviations shown here. Airspeed steady but fast until the very end. Engine N1, both engines working normally all the way to the bitter end, and a desperate attempt to go around at the very last moment once the aircraft broke out of the weather and began sinking well below glide path. 2 applications of the speed brakes, and the gear was lowered a little bit late in the game right here past the final approach fix. But if we widen the data out to the last 14 minutes or so of the flight, we can see exactly where the fatal mistake was made and not captured. Right here at 3:18, hydraulic system B was disabled or turned off. That's when the flight crew inadvertently turned off hydraulic system B instead of turning on the wing anti-ice. This was not captured all the way to the end of the flight. A brief master caution warning went off and the crew immediately extinguished it. As soon as you shut off hydraulic system B, the crew lost the autopilot. Remember, the autopilot on the 737 has Command A or Command B, and you switch them back and forth on the different flights. Well, the crew had the autopilot on Command B or System B, hydraulic system B. As soon as they lost that hydraulic pressure, the autopilot kicked off. There were 2 subsequent attempts to turn the autopilot back on, but the autopilot remained off for the rest of the flight. The engine anti-ice was never turned on. The flaps and slats were never extended. The speed brakes were used a couple of times. Both engines ran perfectly throughout the entire event. Here's your different roll angles, pitch angles, speed steadily decreasing, and altitude. Looking at our overhead view of the entire approach now, this all makes sense. As the comment section said earlier, it didn't make any sense if the crew had inadvertently turned the hydraulic system B off after the flaps were extended, because the flaps would have stayed in that position. Instead, the hydraulic system B was turned off at 03:18. So way back here, prior to the approach, the hydraulic system was disabled, and that mistake was never captured by the crew. And as many of you have mentioned in the comment section on the 737, you've seen this before happen in the aircraft, but you catch that mistake and you simply reinstate the hydraulic system and go on your merry way. Again, the 737 doesn't have an ICAS, an engine indication and crew alerting system, to give the crew a whole checklist of things that are wrong with the aircraft, like is required by modern aircraft and is now being retrofitted to the 737 MAX because of the requirement by Congress had to force Boeing's hand to finally put a proper ICAS system in the 737 MAX design. Remember, you can't maintain the type certificate rating of an aircraft if you significantly change the design of the aircraft, so they had to make an exception to this to get an ICAS system finally put in the 737 MAX. But this is why the 737 MAX should have never been here in the first place. It should have started out as a clean sheet design. Anyways, back to the task at hand. So with System B hydraulics disabled back here prior to the approach, that sets the crew up for a hot, high, and fast approach into Vilnius in the weather. Why? Because they don't have the flaps to help them slow down. Once they realized their mistake much too close to the ground to begin a go-around, the aircraft stalled and impacted the terrain. Here at the final moments of the flight, they had just broken out of the clouds. They were briefly on glide slope, then immediately began sinking below glide slope right here. Here's where the go-round was initiated, much too late, the spool-up time of the engines. As soon as they began slipping below glide slope, they immediately got a stick shaker, followed by a second stick shaker right into impact. The auto throttles to go around were not made until right at the last moment, right here. And here's what the Egypt was doing. From the moment they began to slide below the glide slope, sink rate, pull up, too low terrain. So what were some of the additional holes in the Swiss cheese model of accident investigation that prevented this crew from capturing this error before it was too late? And a lot of that information is found here in the CVR, the cockpit voice recorder. It was the co-pilot who was flying the aircraft, and the captain was the pilot monitoring. The initial departure and cruise part of the flight was uneventful. At 0301, the crew started the approach briefing. They discussed the relevant charts and frequencies and courses. Remember, on earlier updates on this event, we talked about the problems with dealing with the frequency, getting the wrong frequency for the control tower during this approach. At 030625, the crew completed and discussed the descent checklist. They omitted the landing data step. The runway was wet. They should have been required to do a landing analysis to determine just how long their landing rollout would be. Then the crew discussed to expect icing, moderate turbulence, and clouds below 220. Then they were handed off to Vilnius at 133.305. The captain tried to contact Vilnius control reporting to the descent to 290, but got no response. At 030925, the captain made further explanation of the vertical nav descent with the anti-ice on to the relatively new co-pilot. And he's telling the co-pilot that with the anti-ice on, the engines are going to be idling. If the anti-ice was actually on, the engines would be idling at a little higher RPM, and so you need to plan your descent a little more aggressively with the anti-ice on. At 030956, the captain tried to contact Vilnius again. After a discussion with the co-pilot about the correct frequency, the captain changed the frequency and radioed Vilnius at 0310-11. They got the correct frequency, and Vilnius responded and gave him the descent to 10,000 feet. So a little delay on that descent because of radio frequency problems. 031243, the crew discussed again about anti-ice in accordance with the weather conditions. At 031727, if we go back and look at the overlay of the timeline, 0317 would put them right back about here on the approach. At 031727, Vilnius gave them a frequency change. During this radio transmission, the CVR recorded an audible double click. That's the moment that lines up with the data recorder when somebody disabled or turned off the System B hydraulic system. It was probably, it doesn't explain here, but it was probably the pilot monitoring or the captain reaching up there to attempt to turn on the engine anti-ice and instead turned off the System B hydraulic system. At 01732, the captain read back the radio frequency correctly, and that's when the flight data recorder captured the data of the hydraulic system B being turned off. At 031735, just a few seconds later, hydraulic system engine right indicated low pressure, and the autopilot, which was engaged to command B, disconnected, and oral alert was triggered that the autopilot had turned off. A master caution light was also triggered, but was immediately canceled by the crew. That light comes up right on the panel. You just poke it out with your finger like that, kind of an automatic response. 2 additional attempts were made to re-engage autopilot B, but of course it's not going to engage because there's no hydraulic pressure, but the crew didn't catch that. However, they were both unsuccessful to re-engage the autopilot. The co-pilot flew the aircraft from this point forward with the autopilot disengaged, but the auto throttles or auto thrust still working. Now more radio frequency problems. The captain attempted to get a hold of Vilnius approach, and at 0318, he looks like he went back to the last frequency to confirm what the next frequency was, and they corrected the frequency to 120705. All these little things are what's lining up the holes in the Swiss cheese to miss this one critical error. At 031847, they get a hold of Vilnius approach. At 032001, the captain recognized that the autopilot was disconnected at about the same time he attempted to engage the engine anti-ice switches. The point was not further discussed by the crew, so they knew something in the back of their mind, something was up. FDR data shows that the anti-ice switches were not engaged at this time. They were never engaged. At 032242, the crew accomplished the approach checklist, but not the landing checklist. No before landing checklist, at least not at that time. 032257, the co-pilot asked if the anti-ice is on, and the captain confirmed it. Remember, you're supposed to get 2 blue lights up there indicating that the anti-ice is on. 032344, the crew discussed measures to reduce the speed, and the captain deployed the speed brakes and advised the co-pilot to raise the nose. So the captain monitoring has got his hands full in the weather at night with a relatively new co-pilot coming in a little bit high and a little bit hot, helping him manage his approach. The captain is having problems with the radios getting the correct frequency. All these things are adding up to both crew members missing the critical mistake. And also, too, of course, now the co-pilot, the pilot flying, is now having to hand fly the aircraft. So it's all hands on deck with this operation. At 03:24:29, the captain stated for flaps 5. The CVR recorded. So if it's the pilot, if it's the co-pilot flying, the pilot flying should be the one calling for the flaps. But here the captain's kind of helping the FO try to get ahead of the aircraft, telling him, get your flaps out to 5. The CVR recorded an audible several clicks, which was most likely the flaps coming from the flap handle movement. Remember, it's got to pass through those gates. The FDR data showed the actual flap position remained at 0 flaps. On this model of 737, there's no data recording the actual flap handle position, only the actual position of the flaps themselves. 03:24:29 would have put them right in here, this critical phase of flight where they've got to capture the localizer, make this sharp 90-degree turn. They're a little hot, little high, trying to make this turn on in. At 03:26:15, the aircraft reached the final approach phase, and at that time, the co-pilot asked the captain for gear down and flaps 15. The captain stated that they were still very fast, and the co-pilot has to reduce his speed first, because the limit for flaps 15 is 200 knots indicated airspeed. You can get the gear down, no problem, but getting the flaps to 15, you need to be below 200 knots. So at 03:26:15, right about in here, they had a indicated airspeed shown in blue just, well above 200 knots. Yep, right there. The ground speed was well below 200 knots because they had turned into that headwind, but the indicated was still above 200 knots. And it looks like they couldn't get the aircraft slowed down. They hovered right here at 200 knots, above 200 knots indicated airspeed, until the aircraft really started to sinking, basically stalling the aircraft. No flaps, your stall speed's going to be very fast. 03:26:58, time for one more fumble on the radio, and this was not helped by the air traffic controller when she said to contact the tower at 118205 instead of 118.205. The captain responded with 11805. That was not corrected by the tower, and so confusion ensued with the inability of the captain to properly get a hold of the tower for their landing clearance. At 03:27:42, just seconds from impact, they broke out of the weather, and the captain stated that the runway is in sight and the co-pilot should further reduce his speed. This happened simultaneously with the captain recognizing he had selected the wrong frequency. At 03:27:56, the co-pilot recognized that the flaps were retracted, and immediately after this stick shaker activated, sync rate pull up warning was triggered by the EJIPWIZ. At 03:28:02, the crew called for a go-round. The auto throttle was set to go-round mode. The engines accelerated to above 90% N1 at impact. At 03:28:07, too low terrain warning was triggered by the EJIPWIZ. 1 second later, the aircraft impacted into the ground. Four folks on board the aircraft. 2 were passengers, 1 from Germany, 1 from Lithuania. I don't know if any of those passengers were in the jump seat or 737 qualified. They certainly could have helped out had they noticed that the hydraulic switches were turned off instead of the engine anti-ice switches being turned on. This is one of the advantages of having a 3 or 4 cockpit crew during critical phases of flight, like takeoff or landing. That jump seater is there to capture these sort of errors before they become a disaster. So we know exactly why this aircraft crashed, and if you put yourself in this crew's position with this level of data, with some knowledge of the systems of the aircraft, you can also kind of see how this crash happened. Thank you so much for your support of this channel, especially the folks over on Patreon that make this channel possible. See you here.